Welcome to a lesson with Dr. Powell. Let's take a look at this graph. Y is equal to negative absolute value of negative 3x plus 2 minus 1. Okay, let's graph this. Thinking of this as a transformation of y equals absolute value of x. See these absolute value symbols? What's inside of it will represent the horizontal transformations. What's outside of it will represent the y transformations, or what's vertical. So if we're looking at it, what's inside is this. So this will give us the x transformations. Subtract 2 to get negative 3x. Multiply by negative 1, and then divide by 3. Okay, so these are our x transformations. This is what's done to all of our x coordinates. Subtract 2, multiply by negative 1, divide by 3. This represents a shift to the left because you're subtracting your x coordinates. This is reflection. If you multiply by a negative 1, the x values swap places from one side of the axis to the other and vice versa. And then divide by 3 means we go inward. All our values divide in by 3, so you get closer to the y-axis. So these are our horizontal transformations, the pathway right from the inside of the absolute value into the x. So we just talked about that. Now, to get y, we work from the outside of the absolute values, just on the outside, and work outward to y computationally. The first thing that happens computationally to the absolute value is a multiplication by negative 1. So for the vertical transformations, we multiply first by a negative 1. Then after that, we subtract 1. So it looks like first is a reflection, and second is a shift down by 1. So we reflect vertically, and then you shift down 1. Okay, so these are the correct transformations in order. Now let's see how this is going to look. And actually, let's just use two main points for features. Why don't we use 0, 0, and maybe use 1, 1. This is the original graph of y equals absolute value of x, and there's axes right here and here. All right, so let's look at the point 0, 0 and see what happens to it. So for 0, 0, for the x, you subtract 2, so we get negative 2. Then we multiply by negative 1, so we get 2. Then we divide by 3, so we get 2/3. In the y, let's start at 0. We were multiplied by negative 1, it's still 0. Then we shift down 1, or subtract by 1, so it becomes negative 1. So the pinnacle peak of the graph, this feature, is going to occur at this point, 2, 3, negative 1. Now let's see where 1, 1 lands using the same idea. So 1, 1, okay, for the x values, you first subtract 2, get negative 1, and then you multiply by negative 1, so you get 1, then you divide by 3, so you get 1/3. Now for the y's, you first multiply by negative 1, then you subtract 1 to give you negative 2. Okay, so this is where the point 1, 1 will end. Let's see how that looks on the actual graph. Okay, so it looks like what we're going to have is first, this is 2/3, so this is 1 and that. And then we take the point here. This is kind of like the peak point right down here. 2, 3, negative 1. And then we're going to put it right on the graph there. So we put that right here. So -2, 3, -1, that's the pinnacle peak. Now the next point right here, 1, 3, comma, -2. So 1/3 would be over here, and then we go down -2. So it looks like maybe right here. Notice that the graph will be going down like that from the pinnacle peak, and then symmetrically doing the same thing going the other way. So it'll kind of preserve the basic idea of the graph, just kind of turn it and transform it maybe, but it'll still look the same, just kind of reflected down in some way or another and shifted and stretched or compressed or something. But it'll look like this, and that'll be the final result. Thanks for watching.